Mankind has always cooked food using everything from campfires and barbecues to gas and electric stovetops. Now he can use an induction cooktop. It doesn't need a fire, a flame, or a red-hot burner. It uses innovative cooking technology our ancestors never dreamt possible and would swear was pure magic. An induction cooktop doesn't use traditional cooking elements above or below the cooking surface. It uses copper induction coils that generate high-frequency electromagnetic fields. These fields excite the molecules in the pan, creating heat only in the cookware itself. That's why the yolk remains cold, and only what touches the pan cooks. The magic starts with a punching press that stamps computer-generated shapes into sheets of cold-rolled steel. These cutouts fix the position of the induction coils that sit under the glass surface. A press brake bends the four sides of the steel so it will hold a glass ceramic top in place. In the meantime, a machine spray paints the burner box, the visible part of the cooktop. A technician affixes the labels and the power cord onto a housing box that will conceal the induction electronics and coils. She secures the power cord for strain relief. She then attaches the power cord ground and the system ground wire to the housing box. She places a cover on the box and screws it into place. Another technician puts together the induction electronics. These assemblies of circuit boards, cooling fans, and semiconductors drive the cooktop. She covers the electronics with insulation and a metal carrier plate that will support the induction coils. Then she feeds the user interface wires through the top of the coil carrier plate. The technician screws the carrier plate and the electronic assemblies together, then grounds the electronics. Protective tape around the openings will prevent the user interface wires from rubbing against the coil carrier plate. And some insulation will protect the electronic assemblies. She closes that side of the electronic housing box and attaches all the power cables. A sheet of insulation goes on the flip side of the box, where she mounts the electromagnetic coil assemblies. The iron slugs on the back of each coil pod help distribute the electromagnetic energy to the cookware evenly. She connects the coil assembly to the system board. Then she places the remaining 4 coil assemblies onto the carrier plate and connects their leads to the system board. Meanwhile, another technician assembles the components of a glass touch user interface panel. She connects the interface to the steel holder that was bent into shape at the start and is now attached to the black burner box. She covers the cooking surface and control panel with an attractive stainless steel frame, then connects the system board to the control panel. She closes up the other side of the burner box. Then she bolts everything down to complete the cooktop. A technician tests the unit. Using a metal object to activate the electromagnetic field, he verifies that the controls respond properly. He makes sure all 5 induction coils are working and the power output from each coil is correct. The control panel confirms it's a success. Clean, safe, and energy efficient, induction cooktops make cooking food quick and easy.